now I'm pinching the petals of the white rose. They're very fabricy sounding because they're fake flowers. I'm tapping the sleeve of the sleeve. Have a very silky, buttery feeling to them. And they make this little rustling noise. And then next to it is this green leaf. This one is more deeply feeling and sounding. And it has these little vines drawn all over it to mimic a real leaf. And I'm just tapping with a pitter patter motion of the leaf. Attached to the leaf is actually this red rose. This one is made out of much thicker, almost styrofoam material. It's also very stuck in its own shape, if that makes sense. Like if I stretch these petals out, they'll just curl right past. See, each petal is curled to mimic the shape of a rose. Next to that is another white flower. I believe this is a white carnation, but I could be completely wrong. Completely wrong. This one that makes that rustling noise that we heard at the beginning also. This one looks like it's made out of almost sheer white fabric, and it's cut into all these tiny little petals with 3 little incisions on each petal that give it this full look. So we have the white rose, the white flower, this one, and then the leaves. Alright, now let's move on. Can you tell me what this is? This is 1, 2, 3. 1, 2, 3. Can you tell me? You're close. It is a type of ruler. Can you tell me exactly what type of ruler this is? Yeah, let me give you a hint, alright? On this side, we have, let's start, 10 on one side, 20, and then 30. And then on this side, we have 40, 50, 60. Okay. Correct. It's an engineering scale. Here we have, let's go to 10. Let's go to 10, that's on this side. And then we have a normal ruler on this side. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12 inches is one foot. between each inch, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 little tick marks in between the numbers, which you can't quite see that well since it's a bit dark. Let's go to 20. 20. So now every 2 marks is 1 inch, So from here to here is an inch. So how many total tick marks and numbers are we gonna have? Correct. 24. 24. See, with this, you just line it up to what you're trying to measure. Maybe I'm trying to measure how much your vision goes. We are at, let's start you off at 0. So we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I count that right? Let's see. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There we go, because I didn't quite start you off at 0. So then, if I'm trying to draw something that's really, really, really big, maybe in thousands of feet or inches, I can scale it down with this ruler, with this scale. This white color with black tick marks and a plasticky material. Also, all the black tick marks are slightly indented into the plastic, so it makes this sound almost like you're running your fingers across the teeth of a comb. When you scratch it, it also says engineer right there, which I know you can't really read, but it does, and it says Germany, right there. I'm guessing this was made in Germany. Alright. Now, one of my favorite sounds. Can you guess what this is? Even before I turn it around. This is the back, and it has 2 screws. Or I guess 1, 2, 3, 4, 5, 6 screws on the actual body, and then 2 screws on the battery socket. So you can see that little square. And it has 1, 2, 3, 4 little black grips, so it doesn't slide around when you place it on your table. And here has a rough little section or just some writing, some instructions, probably or warnings about the battery. Okay, let me turn her around. On this section is a rough section. Can you guess what it says? I'm not gonna turn the light on just so you can relax your eyes a little bit, but can you tell me what it says? Can you see it shining where the indents are? Okay, I'll spell it out for you. T-E-X-A-S. That's the first word. Then down here it's I-N-S-T-R-U-M-E-N-T-S. And then here's their little logo. Okay. Correct. It's Texas Instruments calculator. Okay, did you hear it click into place? Because the case can have it closed or open. You can slide it on either way. Should we turn it on with the on button? And off, which is just second on. And we have 4 little arrows here, so you can move around. Do you know why you would need to move around? Yes, correct, because this is a graphing calculator. So sometimes when you have a graph on here, you want to move from side to side, maybe pick a point, or sometimes you're just trying to go down and change, I don't know, a menu or a matrix, or you want to say you want to change a number from a calculation. If you did 100 times 100, and you realize it needs to be 100. Well, you want it to be 110. So you can go back as many places as you need, and then change it to 110 instead of 100. Alright. It also has division, multiplication, subtraction. Okay, actually, yeah, and addition down here. So addition, subtraction, multiplication, and division. We have our normal numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a dash, and we have a point. And then on this side, we have a natural log, a log, a squared, and a exponent to the -1. We also have a math function. We have a comma. We have parentheses, right and a left, and then we have a caret. So you can do exponents. We have clear. We have program. We have sine, cosine, tangent, and up here, we have zoom, y equals graph, and trace, and window. Right, these up here are how you graph something. These white ones are how you do any basic calculations, and these red ones are extra functions. Anything that's another color, like this blue or green, basically just lets you select other things, because every single one of these has another little piece of writing. I don't know if you can quite see that. That's in blue. Let's try this on for a second. You can see blue and green and green. So for example, if I pressed second and this, I would get quit, because it says quit up there. So that gives you so many options of anything that you can select. Alright, let's close that up. Okay, we're gonna tap on one more thing. I don't even think I'll be able to fit this all in here, but I thought the sounds might be nice. I love any wood sounds. I just got a bunch of these for my desk drawer, so maybe you can guess what I do for a living. Do you know what this is? Do you know what this is called? Let me see if I can fit the whole thing. Correct. much weight this held before it broke. Actually, I would like to know too, because it looks like I forgot to write it down on here. But we have this dress, and it's called Nice Dress, Nice Dress. And it has the time and date where I did it, And can you guess what type of wood this is? Correct. I don't remember either. Yeah, you're right. You're right that I don't remember, because I did this over a year ago. And you know what these are? They're little gusset plates, yeah. These are just made out of regular plywood, and they actually help adhere all of the different sections of the dress. It's made out of 1, 2, 3, 4, 5, 6, 7, 8 different pieces of wood. It was actually only supposed to be made out of 7 pieces of wood, but we accidentally cut this a little short. This was all supposed to connect at the bottom, but it didn't. That's all right. Okay, and then we have, can you hear the difference between the plywood here, scratching, and the wood? I think this might be oak. Or pine. I'm not that good with knowing my woods. Can you see the grain and how it changes, and how the gusset plates are just glued on here? Can you guess what they're glued with? Gorilla Glue, yes, correct. Gorilla Glue. And then these are little Velcro command strips, so I can actually hang it on my wall. And you can see here is where it's been sanded down, so the gusset plate adhered better with the Gorilla Glue. I think this held about 2,000 pounds, and it was loaded. Well, it was loaded somewhere, I believe. It was loaded here and here at the top, and there was a machine pushing down on it until it broke. You can't even really tell where this one broke, but it was at one of the gusset plates that came undone, just a little bit. So this one was pretty strong. I guess the calculations worked out for me. And on my wall, as I'm scratching this, I also have a beam, an I-beam made out of oak that could hold 3,000 pounds. So you can hear how rough and almost scratchy the plywood is, and how smooth this wood is. It's smooth to the touch, which is why we sanded it down, so the gusset plates adhered really well. Because one of the biggest issues when you're making a truss or a beam only using glue is that you have to account for the sheer strength of the glue, so how it slips almost, because the glue is usually what fails first, and trusses are usually made out of triangles. So can we count how many triangles we have? 1, 2, 3, 4, 4. And do you know what might be made out of a truss? Maybe a bridge. Yeah, correct. actually don't really make truss bridges as much anymore. They do a lot more suspension, especially if they want to span a longer length. Like, okay, I think if I make this video any longer, it's gonna divulge into an entire bridge lesson, which I could go on forever. So I hope you enjoyed the tapping